definition, so here's the definition of a reference angle. It's a positive angle between the terminal arm, that's where an angle ends, and the nearest x-axis. So because it's to the nearest x-axis, that angle will always be between 0 and 90 degrees. So what we're going to do is we're going to look at all 4 quadrants, and we're going to look at angles that have the same reference angle. So if I pick a random angle here, let's pick a not so random angle. Let's pick a nice one like 45 degrees. So there it is in quadrant 1. That's 45 degrees because we go from there to there is 45 degrees. To the nearest x-axis, that would be right here. We would say in quadrant 1, the reference angle for this one would also be 45 degrees because that's how far it is from the x-axis. The terminal arm to the x-axis is exactly the same as the angle is in standard position. But if we go to quadrant 2 and draw an angle in quadrant 2 of 135 degrees, this angle to the nearest x-axis would be here. And again, this is where it's important that you know that this is 0, 90, 180, 270. Don't forget the degree signs. If you know it's 180 all the way to this x-axis, it's not hard to figure out. If I want to know how big that reference angle is, it's just going to be 180 degrees minus the 135, and that will give me what's left, which is 45 degrees again. So both of those angles have the same reference angle. In quadrant 3, there's an angle in quadrant 3. My reference angle to the nearest x-axis would be this one. If I want that reference angle to be 45 degrees, what would I need my original angle to be? 225. Of course, if I told you 225 to start off with, and since you know that it's 180 up to here, to figure out that it's 45 degrees, you would say, well, I know that my reference angle would be 225 minus the 180. And that would give me this little blue part that's left. And finally, if we pick one in quadrant 4 that has that same thing, this angle of 315 degrees would also have a reference angle equal to 45 degrees. And if you had to figure that out, well, all the way around once is 360, so you could figure out that reference angle is 45 by saying, well, 360 minus the 315 degrees that we know is the blue angle would give me that little green part that's left, which would be 45 degrees. Now, reference angles are important, especially this year, because we're going to find out if we know how things act in quadrant 1, we're going to know how they act in all the quadrants. And all we have to do is know what's happening to the reference angle, and then we're going to know what's happening to all angles for sine, cos, and tan. Now, going back to what we've learned about sine, cos, and tan and right-angled triangles, sine is opposite over hypotenuse, cos is the adjacent over hypotenuse, and tangent is the ratio of the opposite over adjacent. And that always has to do with right-angled triangles. The reason that it works, that we can say things about sine, cos, and tan in the other ones, is because if you were to make a triangle here with 45 degrees, that would be the same triangle that you would make if you made a right-angled triangle over there, which would be exactly the same triangle you could make if you made one there in quadrant 3 or one here in quadrant 4. So what I'm going to get you to do with your calculators right now is calculate sine, cos, and tan of 45 degrees first. Then do sine, cos, and tan of 135 degrees. We'll go to 3 decimal places where necessary. Sine, cos, and tan of 225 degrees. And sine, cos, and tan of 315 degrees. Just so that it goes quicker, we'll get this row quadrant 1, this row quadrant 2, quadrant 3, quadrant 4, quadrant 1, quadrant 2, quadrant 3. Once someone in your row has figured out what the answers are, they can come up and write them on the board, and then we'll have all the answers quickly. So if you've got your calculator out already and you've got sine, cos, and tan for one of those, this one's 1, 2, 3, 4, 1, 2, 3. We'll put them up there and see what we get as results to 3 decimal places. All right, so here we have the results. What we're going to do next is circle all the positive ones. So in the first quadrant, hope you notice that they're all positive. We also noticed that the numbers didn't change here at all. And I chose 45 degrees. 45 degrees is the only one where the sine and the cos are the same. Any other angle, the sine and cos would be different. So this is the one time that we notice a pattern where sine and cos are the same. If I had chosen a different angle, then we would have got different values for sine and cos. But those are the positive ones. Once we get to quadrant 2, the sine is the positive one, and the only one that's positive. Quadrant 3, the tan is the only one that's positive, and in quadrant 4, cos is the only one that's positive. And this may remind you of another thing that you've learned in grade 11, which is sometimes called the cast rule. And what the cast rule is just telling us is where things are positive and where things are negative. So the C in quadrant 4 here is because here in quadrant 4, only cos is positive and sine and tan are negative. The A for quadrant 1 means that all of them are positive. In quadrant 2, we have an S. Because only sine is positive. And in quadrant 3, we have a T because only tan is positive. And I guess we don't call it the aesthetic rule because it doesn't roll off the tongue as nicely as when you say cast rule. But it's just an acronym, again, to help you remember what things are positive in what quadrants. So the idea is if you know what's happening in quadrant 1, then you know what's happening in all quadrants. The only thing that changes is sometimes the answers are positive and sometimes the answers are negative. And you now also know anything beyond that. So if I would take an angle that was, say, for example, 495 degrees. 495 degrees ends in quadrant 2. It's coterminal with 135 degrees. It has a reference angle of 45 degrees. So what we're often going to do with a question like, say, find sine of 495 degrees. What you're going to figure out is you're going to figure out that the reference angle is 45 degrees. And because it's 45 degrees, you know that it's going to equal 0.707, either positive or negative. But then you're also going to figure out that 495 degrees ends in quadrant 2. And according to the cast rule, sine is positive in quadrant 2. So sine of 495 degrees will equal 0.707. Those are some of the things that we're going to do. You're going to know something about how it happens in quadrant 1, and then be able to figure out what's happening with angles wherever they end. So this is a big idea that way. Okay, let's go to example 1.